All right, here's your lesson on the remainder theorem, factor theorem, and synthetic substitution, all connected. So here we have a polynomial. If you divide, we're going to use synthetic division. So we're going to use the 0, which is -4. And we have 1x cubed, 1x squared, -4x, and 41. No powers are missing. If you put the lines in here to help organize it a little bit better, we're going to add and then multiply and then add and then multiply. Get your signs right. And you'll notice the answer at the end. The remainder is 9. Now, if you do an evaluation, so if you evaluate at -4, so -4 cubed, -4 squared, -4 times -4 plus 41, and you actually did that work, I want you to notice the answers match. And I'm going to tell you that -4 times -4 times -4 and then and so on, that's a lot longer way to do a substitution. We are going to learn there's a new, faster way to substitute in, and it's called synthetic division or synthetic substitution. Let's try it again. If I divide by x minus sign, the 0 is positive 9, and we have 7x to the 4th, -63. We have no x squares, 9x, and -81. You can put the lines in to help organize it a little bit, and then drop and then multiply. And if I did the same work and substitute in 9 into the equation, can you just see how hard that would be without a calculator? How much calculating you would have to do, how much multiplying you would have to do, and adding and subtracting, and you end up with the same answer. If you put that in the calculator, that's your answer. So we're going to work on synthetic substitution as a way to evaluate. So if a polynomial f at x is divided by x minus c, then the remainder is f at c. Using synthetic division to evaluate a function is called synthetic substitution. Okay, so how is this going to work? So how do I evaluate when it's -3? Instead of plugging in -3, and it gives you -3, so I don't change the sign. If this said x minus 3, then it would be positive. But it just gives you -3. We use it. 1x to the 4th, 8x cubed, 12x squared, -7x, -14. Put your lines in here, and then we are going to add and multiply across. So -3 times 1, add. -3 times 5, add. Negative, that's 9. 9 and -7. And then -3 times 2, and then you get your answer. Now that answer means that f at -3 is -20. This is the conclusion we're making. The remainder is my answer I'm looking for. Number 4, just a little. So number 4 again, I want to evaluate at 1. So the number I see is what I put down. 3x over 2x to the 4th, 4x cubed, 3x squared, 2, -3. Put the lines in if you like. Our whole goal is to get this remainder at the end. So we're going to add, and then we multiply, and then we add, and then we multiply. Keep that up all the way down, and then you get your answer. So f at 1 is equal to 11. All right, turn the page. Again, we're going to evaluate at -5. We need the 0 at the end because we're missing that number to get the right answer. So we have 1, -5. Well, that's a tricky one. That's 95. I went 5 times 20 and then took away a 5. Yay. 95 take away 23. Why does my brain just want to do that? That's 72. Jeez Louise. 72 times 5. That's 10. 360. And that's the answer that we're looking for. So notice if I didn't put down 0, I would get the wrong answer. So f at -5 is equal to -360. All right, let's try again. Number 6, can you evaluate at -2? Be careful of missing powers. So we have 2, 4, we have no x squares. So make sure a 0 is there. And then we multiply and add across. And it's this remainder at the end that gives me the answer. So we constantly add and multiply and add and multiply until we get to the end following the pattern. Okay, number 7, I want to evaluate at 7. Be really careful of all the powers that are missing. 8x cubed, negative 5x squared, 0x, and negative 1. So 8 and nothing. 7 times 8 is 56. Add the numbers, 51. Oof, 7 times 50, and then 5 more, so that's 355. Oh my goodness. And then, I don't want to do it, but I will. 355 times 7, 35, 35 and 3, 21 and 3. So it's 2,485. Subtract 1, so it's 2,484. And so if I plugged in 7, that's the answer. It's still way easier than plugging in and trying to do it the old-fashioned way. Okay, one more time. 8. Evaluate at 4. You have negative 2, 7, 2, 0, negative 1, and 8. And then we're going to add, and then we're going to multiply. That's negative 120 and 12, 132. That's negative 124. So that means when you evaluate at 4, the answer is negative 124. All right, some simple stories. The number of tickets sold during the football season can be modeled by this equation. X is the number of games played. Use the remainder theorem. Find how many number of tickets sold during the 7th game. So I want to evaluate at 7. And it's 1x cubed minus negative 14, 72, and 68. So again, 1, and then 7 times 1, and add, multiply it together. 323, oh my goodness, 140 and 21, so 161. And, all right, so 229 tickets were sold. I think I did that right. I hope I did it right. Looks good. All right, another story. The distance in feet that a person travels on a snowboard is this equation. T is the time in seconds. Find the distance traveled after 1 minute. So I need that in seconds, so it's 60 seconds. So I'm going to evaluate at 60. I have 0.6, I have 10, and I have 0, because I need that number at the end. So 0.6, so 6 times 6 is 36, and so it's 360. Move the decimal, and it's 36, and then I got 46 times 60. That's 2,760. So how far did they travel? And that's in what? Feet? Yep. $2,760 feet. All right, there's half the lesson. Turn the page over here. Here's the other half. The remainder theorem, synthetic substitution, can be used also to know if something is a factor. So if f at c, if you evaluate and the answer is 0, then x minus c is a factor of f at x. So how does that work? So if I want to know if these are factors, I take the 0 from these factors, so like negative 1, and I want to see if the remainder is 0. Now, don't forget the missing term. All I care about is if the remainder at the end is 0. So 1, negative 1, negative, negative, positive. That's negative 30. And there. And so notice the remainder is not 0, so this is not a factor. Let me double check. I'm sure I'm perfect, which I'm not. But I think so. Good. Now, what's the 0 from here? Positive 5. Again, 1, 0, negative 31 and 30. So let's put the lines in there so you can see it. This one does give me a remainder of 0. So therefore, this is a factor. Now, what's left over is 1, 5, and negative 6. So you can use what's left over if the remainder is 0, and it's a shorter way then. Use negative 6 and C, and it gives you the answer 0. So if the remainder is 0, then this is a factor. If it's not 0, we cross it out and it's not a factor. All right, let's try again. Is this a factor? And as soon as we find an answer, we can use the shorter form of the equation. Let me see if this gives me the remainder of 0. And it does. So blurry. And then I'm just going to use the answer without the remainder. And I'm going to try negative 7. What is this, 52? This is not happening. So as soon as I notice, so this is negative 364. As soon as I notice this is not going to give me 0, I'm not going to continue. I know already that no matter what, this is not going to give me the answer I'm looking for. So I stop. This one does not work. And then try negative 4 with the same numbers. 1, negative 4, negative 25, and 28. And I want to see if the remainder is 0. So drop down the 1, multiply, add, multiply, add, multiply. And you can see this one does give me the remainder of 0. So the two factors are those two. Why? Because the remainder is 0. If it's not 0, we cross it out. It is not a factor. All right. Use the factor theorem and the given binomial to completely factor it. So here I have given that x plus 3 is a factor. So I know that when I divide, the answer is 0 at the end. But I still need to know what the answer is. So I'm going to go drop the 1, negative 3 times 1, negative 3 times 0, a negative times a negative. And you can see the remainder is 0. Now, to see what's left, the dividend, like what we started with, was x cubed. Our answer is 1 degree less, so it'll be x squared. So 1x squared, no x's, minus 4. And then if I factor this is called a difference of squares. So you square root x squared and square root 4. And then if we put it all together, we had the first factor, x plus 3, and then the two factors we found afterwards, and now it's completely factored. Turn the page. So again, we're going to take the 0 and we're going to divide, and we're going to see that the remainder is 0. And then what's left over is 1x squared plus 3x minus 4. So those, what two numbers multiply to negative 4 and add to 3 are positive 1 and negative 4, or negative 1. And then if I put it all together, so the first factor is x minus 5, then x plus 4, then x minus 1, and you factored it. Let's try it again. So use it. You're given one of the factors. That's 2, negative 7, negative 53, and 28. And then I multiply and add. Notice I know that it's going to be 0. What's left over is 2x squared, 7x minus 4. To do this, the first number times the last number. And the two numbers that fit are 8 and negative 1. Then I'm going to divide by 2, and then I have my answer. So I have my original factor, which is x minus 7. Then 8 divided by 2, that's 4. And then 1/2 is in lowest terms. Slide the 2 in front, and you have all the factors. Number 6. Again, I'm going to use the 0, negative 2. So we have 9, negative 18, negative 73, Nothing's missing, 2 and 8. This should give me the answer 0 if I do it right. And then what's left over is 9x cubed minus 36x squared minus 1x plus 4. To factor this, I group them, so I'm going to factor out 9x squared from the first two terms, factor out negative 1, and then I have 9x squared minus 1 and x minus 4. That's a difference of squares, so the original is x plus 2. The square root of 9x squared and the square root of 1. So one's 3x plus 1, one's 3x minus 1, and x minus 4, and you have completely factored it. All right, two more. Number 7, take the 0, which is negative 5. So 3, 5, negative 42, 40, and 0. Let's see, make sure we do it right. What am I doing wrong here? So negative 5, 3, 5, negative 42, and 40. So I have 3, make sure I'm doing this right, negative 10, that's positive 50. I knew I made a mistake somewhere. It's all good. That's positive 8, negative 40, that's 0. So what I'm left with is 3x cubed minus 10x squared plus 8x. Now, I could factor out an x. I could have done that at the beginning too. So when I do this, the first number times the last number and negative 10, find the two numbers that fit. So negative 6 and negative 4, add to negative 10, multiply to 24. So I have x minus 6 and x minus 4. I got to divide by 3. And now I have all my answers. So I'm going to just start with x. And then the original factor was x plus 5. And when you divide by 3, 6 divided by 3 is 2. Divide by 3 is a fraction, so it slides in front. So it's 3x minus 4. All right, last one for the lesson. So positive 3. We have 4, negative 12, negative 13. Oh boy, 39, and 9, and negative 27. Let's see where this leads. So we have 4, and then 12, and then 0, negative 13, negative 39, 0. 0, 9, and 27. So there we go. So we have 4x to the 4th minus 13x squared. There's no x cubed, no x's, and then plus 9. I'm going to factor this. So first number times the last number. That's 36. And negative 13. The two numbers are negative 4 and negative 9. So negative 4 and negative 9. Now again, it's squared, but I got to divide by 4. So I have x squared minus 1 and x squared minus 9 over 4. Now these are both difference of squares. So when I write my answer at the end, we have x minus 3. X squared take away 1 is going to be x plus 1, x minus 1. Here, when I square root a fraction, it's going to be 3 over 2, and you're going to slide the 2. So it's 3 over 2, and you're going to slide the 2. So one's 2x plus 3, and the other was 2x subtract 3. It's over. Mr. G Math over and out. So there was your lesson. Factor theorem, remainder theorem, synthetic substitution. Now we need to practice doing our homework.